Okay, hopefully I've got enough computer battery here to get through this lesson without my laptop dying on me. So, today's lesson, you will notice in Schoology that it is for November 6th, not 16th, 17th and 18th. Okay, so what was assigned on Schoology for the 16th? My students were still working on workbook pages from the workbook page during the majority of their class time today. All right, for most of my classes. So we did not complete this lesson on the 17th, so we're completing it on the 18th. So, for those of you that might be learning from home, we are simply just taking this lesson and working on it over a 2-day period. Okay. Those of you that were in class with me, you're getting a little bit of review from what we did yesterday and then moving on with it. All right. So, unit rates. We are still talking about unit rates. All right. Yesterday, the people that were with me, we reviewed a little bit about what we've talked about as far as ratios, rates, making some connections between all of the strategies there. All right. Those of you that have been doing the video lessons, those were pointed out to you along the way as well. All right. So, our first problem for today is going to be this one here. So, we've got Chloe, and once she loads up here, all right, Chloe is driving on the freeway. She is 200 miles from Los Angeles. She drives at a constant speed of 55 miles per hour. Can Chloe get to Los Angeles in less than 3.5 hours? Okay, so let's think about it. We've got some good information here, right? Total distance of 200 miles. Okay. We have her rate, 55 miles per hour. So she wants to get here. Let's say she's here. All right. So a total of 200 miles. And we can look at this a couple of different ways. Okay. We can look at this and go, okay, I could take this 200 and divide it up by the miles she travels per hour. All right. Because each hour is 55 miles, right? So if I take that 200 and divide it by 55, that will tell me how many hours it's going to take her. Okay. And then I can look at that and say, okay, is that less than 3.5 hours? So I could solve it that way. So let's do that. All right. 55, 200 divided by 55. Well, I can't do 2 divided by 55. Can't be 20 divided by 50. So I've got to stick to the 200 divided by 55. Well, I know 50 plus 50. 50 times 2 would be 100, right? So let's do 55 times 3. Let's try it out. See what we get. All right. So 55 times 3. 3 times 5 is 15. 5 carry your 1. 3 times 5 is 15. Plus 1 more is 16. 165. So subtract 165. Well, we are going to have to do some borrowing, right? 10, 9, 1. 10 minus 5 is 5. 9 minus 6 is 3. Nothing to bring down, so that's my leftover. What does that mean for me? Well, I'm calculating hours, right? Well, that's not 35 hours left over. It's part of my hours, right? So we could think of this as 3 hours and 35 minutes. 3 hours and 35 minutes. Is that less than 3.5 hours? Well, what's half an hour? 30 minutes, right? So is 3 hours and 35 minutes less than 3 hours and 30 minutes? No, right? I had students in class today that did this a different way. You can also do this the opposite way. You could say, okay, so 3.5 hours, we can take her rate for every 1 hour. We could think of this every 1 hour is 55 miles. So really we're taking this and we're repeating that hour over and over again for 55 miles, 55 miles, 55 miles until she gets to her destination, right? So that would be multiplication. So we can take 55 and multiply it times 3.5. And of course, we would want to change this. There's even a student of mine that thought of this. Okay, well, we could do 55 times 3. Well, what is 55 times 3? Well, we know that, right? 165. We did that earlier. And then we could do 55 times 1/2. Well, 55 times 1/2, that's half of 55. So 55 divided by 2. This would be 2, subtract 4, you're left with 1, bring down your 5, 15. Divided by 2 is 7, minus 14 would leave us with 1, so 27.5. So we want to take that 27.5 and add it to 165. So 1/2 stays, right? And we have 5 plus 7, which would be 12, right? 7, 8, 9, 10, 11, 12, yeah. 2, carry my 1. 6 plus 1 is 7, plus 2 more is 9. 192.5 miles. So if she's traveling at that rate, she's going to make it 192.5 miles in 3.5 hours. Is that 200 miles? No, it is not, right? So 2 different ways to look at the same problem. All right. If we were doing this in class, you could look at the different strategies, those 2 strategies that we just talked about, which is what we did in class. We talked about the different ways to find the same answer in the majority of my classes. I think my first math class, they all did it the same way. All right. Number 2, a look ahead. Okay, so looking ahead gets your brain wrapping around where they're wanting you to move to. All right, one of my classes got to this, another class got to part of this, so we're just going over the whole thing again. Okay, so Chloe's constant speed of 55 miles per hour is a rate. 55 miles per hour is a rate. We've done rates, right? $8 per pound. That's a rate. 3 feet per second. That's a rate, right? Now we're going to look at something called a unit rate. The numerical part of the rate is called the unit rate. In this case, 55 is the unit rate of that 55 miles per hour, which means 8 is the numerical part, right? 8 is the unit for this rate. 3 is the unit for that rate, okay? Don't try to make that complicated. Just know that it is, okay? It is. Some of my students in class today were trying to wrap their brain around that, and just know that because when we talked about rates in the beginning, we said it's units per 1 unit, right? So that is if it's units per 1, then our unit is that first part of our ratio, or of our rate, if that makes sense to you. So A says, what does the unit rate 55 tell you in this situation? What information is the 55 giving you? Well, it tells you how many miles. So it tells you how many miles, or the distance, right? B, on another trip, Chloe drives at a constant speed of 60 miles per hour. What is Chloe's unit rate? 60 miles per hour is the rate. The numerical part is going to be our unit rate, right? So what is the unit rate in this case? 60, right? What does 60 tell you? It tells you the miles, right? Okay, so C. The table shows that Chloe travels 240 miles in 4 hours. 240 miles, 4 hours. Complete the equivalent ratios in the first 2 columns. So, boop, we're here. We're not over in the third column. Ignore third column for now, okay? Complete the equivalent ratio in the first two columns. Where do you see Chloe's unit rate? Unit rate. We have a rate of 60 miles per hour. Unit rate. 60 per hour. Right there. Our unit was 60, right? So now this makes this even easier to complete this chart. So we have 1, 2, if we keep following the pattern, 3, 4, 5, right? Then over here, we're counting by, anybody notice it? We're counting by 60s, right? So 120. And then down here, we would have 300. All right. You could go and look at ratio relationships here and go, okay, 1 to 2 times 2, 60 times 2 is 120, right? You could do that. You could go, okay, to get from 60 to 180, I would multiply times 3. So 1 times 3 is 3. You could definitely do that. All right. So we see Chloe's unit rate or unit right there. Unit rate is 60. The third column of the table shows the quotient of the numbers in each equivalent ratio. Complete the third column. What do you notice? Okay, so we have A over B. That's the same thing as A divided by B. That's what that's saying. Okay, so if we write this 60 to 1, 60 to 1, right? That's equal to 60 divided by 1. What is 60 divided by 1? 60. 120 to 2. 120 to 2 is the same thing as 120 divided by 2. Well, what is 120 divided by 2? 60. 180 divided by 2. Well, what is that? 60, right? This one is done for you. Then we have 300 over 5 for 3 to 5. 300 divided by 5. What's that going to be? 60. So, what do you notice? I notice that the quotient in each equivalent ratio is the same. That's what I notice. All right. So when I find the quotient in each equivalent ratio, found the quotient of 60 to 1, found the quotient of 120 to 2, found the quotient of 180 to 3. Every time I did that, every time I find the quotient of my equivalent ratios, I get 60. So that's what I noticed about my chart. All right, so all of this gets our brain ready for what we're about to do. All right, how can you use rates to help you identify equivalent ratios? So think about that for a minute and answer that question. I'm not going to go over that one with you. I want that to be your own reflection there, and then I'll look back at it when you're done. So how can you use unit rates to help you identify equivalent ratios? If you're not sure, you can write, I'm not sure. Okay, I don't encourage that. Please try to write an answer, but don't sit there stuck on that all of your class period. All right. Ashwini jogs on the track at her school. She uses a watch to track her progress. At this rate, how long will it take her to jog 16 laps? All right, so we've got 15 minutes for 6 laps, right? So we want to know a rate. And this is a strategy that your curriculum suggests, okay? So in this strategy, we have our original ratio of 6 to 15, right? And we want to know how long it takes her for each lap because we're wanting to know length of time, which means our laps need to be 1, right? So if we find our rate, then we want to know how we get from 6 to 1, right? We divide by 6. So we do that over here, divide by 6, and we're going to get 2 and 5/10. All right, so they did not write that one as a fraction, and that's fine. So what they did was they did 15 divided by 6. Well, 2 minus 12, we're left with 3, right? Add a decimal point, carry it straight up, add a 0, extend our bar, right? Drop that down, so now we have 30. 30 divided by 6 is 5. Subtract 30, we get 0, right? That's where they got that, okay? Now that I know my rate, I can figure out how long it's going to take her to jog 16 laps. 16 laps. So for every 1 lap, to get from 1 to 16, I multiply by 16. This is where those equivalent ratio tables come in for every lesson. All right. It is a strategy that can be used repeatedly. So again, consistency is nice, right? So if I do times 16 over there, I have to do times 16 over here. All right. So that's a strategy for you. So figure out what 2 and 5/10 times 16 is going to be. Now, this is a fluency standard, so please work it on your own first, then come back and check your answer on the video. All right. 6 times 5 is 30. 0. Regroup your 3. 6 times 2 is 12. Plus 3. 12, 13, 14, 15, right? Put a 0. We're moving over to the tens place, right? 1 times 5 is 5. 1 times 2 is 2. We add it together. This was a 0, by the way. So we have 0. 5 plus 5 is 10. 0, carry your 1. 2, 3, 4, right? 400. But we have a decimal place value here, right? There's a decimal point right there. It's not coming out too well on the screen. So we need 1 decimal place value here. So we have 40 minutes. It's going to take her, because we have this, right? So we can drop that 0 at the end. 40 minutes. 40 minutes to do 16 laps. All right, so that's a strategy, right? Now it says compare strategies, so we're going to be looking at a different strategy now, okay? Okay, you can find the unit rate and then use it to find equivalent ratios. So divide the numbers in the ratio 15 to 6 to find the unit rate for laps or minutes per lap. So you don't have to find a rate. You can just take your 2 parts, minutes to laps, and divide them. All right? Set them up as fractions and divide them, which is what they did. So going back, let's go back for just a minute. Our original ratio is 15 to 6 minutes per lap, right? 15 to 6. That is what they did here. 15 to 6 minutes per lap. And we want to know per lap. So that's why lap is what we're dividing by. Okay, if we want to know per minute, we would divide by minutes. Okay, but we want to know per lap. So per lap, we do 15 divided by 6, which is 15 over 6. They went ahead and reduced that. Okay, you could go ahead and do 15 divided by 6 if you wanted to. You don't have to reduce it first. So 15 divided by 6, we have 2, right? We just did this. That's 12, 3, add a decimal point, bring it up, add your 0, drop the 0. Now we have 30. 30 divided by 6 is 5. 5 times 6 is 30. And you get 0, right? So 2 and 5/10 minutes per lap. That's our rate. So we can do that just automatically without the table to find our rate. And then we use that in to multiply the number of laps by that unit. Okay, that's what we were doing in the previous strategy, anyways. It's not broken down and step by step on the table, it's all outside of the table. So I know that it's 2.5 or 2 5/10 minutes for one lap, and I want 16 laps. So I want to multiply that, which we also just did in the previous problem, right? And we said that 5 times 6 is 30, 0. Regroup your 3. 5 times 1 is 5, plus 3 more is 8. Add a 0. 2 times 6 is 12, so 2. Regroup your 1. 2 times 1 is 2, plus the 1 that you regrouped. 2 plus 1 is 3. All right, add this together. You get 400, right? But we've got a decimal place value. So we put a decimal point there. So we have 40 minutes to swim 16 laps. All right, so we get our answer there as well. So 2 different strategies. You have them both there as a reference when looking at problems coming up. Okay? All right, let's check it out. Okay, how long will it take Ashwini? I don't know. How long will it take this person to jog 22 laps? So we know a rate for this person, right? What was the rate in laps or minutes per lap? We had 2 5/10 minutes per lap, right? How long will it take